see you.
Hi, how are you?
Very good, good to see you.
Yeah, me too. I guess that you know Dennis Lamb.
Oh, of course.
Yes.
Dennis actually hired me at DRI.
Ah, yes.
Years and years and years and years and years ago.
So you know that we are in contact quite frequently?
No, I didn't know.
Ah, yes, because I was there at Penn State University at 2002, 3 and 4. I was there 3 times. And we wrote papers together. And
Yeah. Dennis is great. How's he doing?
He's fine.
Yes.
Yes.
Because I know he retired.
Yes, he's now living in He's now living in Fort Collins.
Really?
Yes. Yes, he decided to move back to the West.
Yeah, but not to Reno.
No, that's right. Yes, so he's
good.
Yeah.
Yeah.
So I wish you success.
Thank you.
Thank you.
Yeah, no, thank you. Actually, yeah, I need to, I've got some questions. I'm looking, I just, I didn't actually just talk about the sense of the work that we did in Darrow. And I was looking at some of the, just basic meteorological conditions that prevail. Of course, I think that's much of your paper. So yeah, as I go through, I'll follow some more.
Yes, now in the matter of fact, that just now recently by coincidence, we were speaking, there are 2 centimeters. One is located in Tel Aviv, and the second one is in the Dallas. And the head of the Ministry of the head of the Ministry of the Israel Meteorological Service told me that those kilometers ahead, they have a database of lasting something like 5 years, and he's willing to give me the data because nobody wants to use it. So I went there with one of my students, and we got the data, and we begin to work on it. I see that there is I see that you wrote a paper about the result of a cylometer post in I think so. She wrote something like 2 papers about the result of cylometers.
Okay, so I don't have it.
Yeah.
Well, actually, if you could.
Yeah, I'll write down maybe the name.
Yeah. Because that would be very, very helpful over there. Yeah.
I guess it's less.
Okay.
And she wrote a paper, both of the papers that I just had a quick look at it, but I do remember that both of them are co-authored by Pinchas as well.
Okay.
So you will find Lene Suzanne and Phil Hassan. Okay, I'll leave you because you have to begin, I guess.
Okay.
If you enter into Google or something, if
right.
you have any difficulty, please just let me know and I will send.
Great. No, that'd be perfect. Okay. Great. Okay. Thank you very much.
Processes of gas to particle conversion. He's the president of the International Unit of Air Pollution Prevention and Environmental Protection Agencies. And today he'll talk about methods and studies to assess pollutant sources and impacts in the Middle East. Tomorrow, 12 o'clock, the CAO seminar will be given by Jonathan Arias. We'll be talking about ocean acidification. And next week, on Wednesday, is the treatment symposium.
Okay, thank you. Thank you, everybody. Thank you for welcoming me, and thank you for just everything over the past 11 months. I've interacted with a number of you, but I've been back and forth between here and Tel Aviv and various other areas. And actually, I'm going to talk a little bit about some of the work that I've done while I was here during this period. But today, the focus will be on a lot of the work that I've done over the years in this region, dealing with air quality issues. And so I'm going to talk about a series of source apportionment studies that I did in Cairo. This is Cairo on a bad day, okay, but that's, you know, it's one of those days when you get to the hotel and you look down and you're at the 10th floor and you can't see the ground. There are lots of places like that, and I get to see that.
Is it desert dust or just pollution?
You'll see. In this case, that day is pollution over there. It is not the Hamza. And then some of the other work that I did in conjunction with Menachem Luria from here on USAID, a series of projects that be transboundary transported pollutants. And then if time, some of the other work done regionally during the last Gulf War, where we collected a series of samples designed to quantify and characterize the particulates that were present, just in case we were dealing with Gulf War syndrome 2. So lots of that data, so we'll see. And that work was actually done with Eric McDonald, who you know from here. So, you know, why don't we look at it? Here's an example. This is from a recent WHO report looking at air pollution worldwide. If you look at Cairo, it's listing Cairo at roughly annual average PM 2.5 levels of about, in this case, let's call it 70 micrograms per cubic meter. What does that mean? If you look at the health effects studies, what they show is that about a 20 microgram per cubic meter annual average of PM 2.5 leads to about a 14% increase in the mortality rate ratio. So this is significantly high. You've got significant health effects in this case. If you look at these cities. So here's Beijing, Delhi, Karachi, you're way above. So we have various air quality standards designed to protect human health and welfare. I will tell you, this is an average for a number of sites in Cairo. And I will also tell you that I think this is an underestimate. I'll show you some data why. Also, with respect to, let's say, the Israeli case, I pulled up this data set because I was, as Uri and I were just talking when we walked in, I'm looking at some data around Hadera. And so I looked to see what they had for Israel. They listed about 10 locations. Hadera came in at an annual average of 16. It turned out to be the cleanest city in Israel. It's such a brag. Givaram came in at 28. It doesn't pass the laugh test when I start looking at this over here. So I think a lot of this data is just what's important. In many cases, it's really often an underestimate over here. But just based upon this high levels, if you look at some earlier data that we had from Cairo when we first started doing the work, this was at the Shoga Al Khamenei site, and so this was showing an annual average of over 200 microgram per cubic meter just at the one site. This site, by the way, happens to be located on top of the school. So if you look at the 4 groups that are most likely to be affected by air pollution, it's the elderly, it's asthmatics, it's athletes because they process a lot of air when they move, and it's children. So yeah, not a good day. Even worse when you start looking at the lead levels. That one site, in 1 year, it averaged over 10 microgram per cubic meter just of lead in the fine fraction. The previous year was over 20. So when you talk to the kids, when you see these kids on top of the school, when I be up there with the samplers, I can see the lead striations in their teeth, just from the lead in the air. So severe air pollution in Cairo. So U.S. Agency for International Development sponsored a project called the Cairo Air Improvement Project, and it was designed to really work to improve air quality in the region. It had a number of different components, one of which was doing source apportionment work designed to determine what are the sources of the air pollutants to put in interventions. And so that was what I was involved with over here, and that's what I'm going to show you. We did additional study, some of the work was in 1999, 2002. We did some additional studies in 2010, I'll show you those. This was a picture took in Cairo, gives you an idea of the nature of the problem. This was further south. These are all brick kilns burning mazout. The ones where you see the white plumes, those are actually some secondary lead smelters. This was a coking chemical plant over there, and the past 5 directors have died of cancer. Good news was they lived long enough to get cancer. The workers were dying at 35, traffic in Quality Square, burning garbage in the streets, typical of what you may see, cement plants, agriculture burning bombs. So you have all of those other issues. The approach we took for these studies is really looking, we put samples on filters, both Teflon filters, quartz filters. We'd send them back to our institute in Reno. We'd do the analysis. We look for mass, tiniest metals, polyaromatic hydrocarbons, because we use those in the fingerprints. We'd also do volatile organic carbon, and we then used to come up with mass balance receptor model to determine the sources. So that was really what we looked at. Again, a number of studies in 1999, 2002, and another study done in 2010. So this actually going to be interesting because what you'll see from this is we were able to work with them to put in some interventions and actually see some improvement. Because sometimes you don't see it, you don't realize it. Yesterday evening, because of the time difference, I'm always working, it's a 10-hour time difference for me back home, so I'm always getting these calls, and I had gotten a call from a reporter, because the issue there was they wanted to know what was going on with the rollback in mobile source standards, what kind of an effect was it going to have with we see any difference. So, you know, when people ask that question, you want to know, did you do this, did you see a difference? Sometimes it's hard to answer. Sometimes you can say, well, it hasn't gotten worse, that's good. And, well, that doesn't cut it. But I'll be able to show you that we're able to see a difference. So we had a number of sites, and the early ones set up. We had Kaha up north, agricultural. This was a show about Mini, Colony Square, Zamalek's on an island in the Nile, fairly high rent district over there. And then further south, in the other studies, we went even further south over there. And so what you have is you've got a lot of these industrial areas. And what did we see? So these are just some of the 1999 work I'm going to show you as things changed. If we are looking at the Shobra area during that period, this is PM10. The average for this is roughly 1 month. It was 2 different periods, about 2 weeks of each site, so roughly a month of measurements. So they were averaging over 250 micrograms per cubic meter of PM10. Okay. So fairly high levels. What we saw at Shobra, what you have when you're looking at particulates in the atmosphere, of course, a lot of PM10 in most areas, getting to your initial point, is going to be dust, soil, windblown. That's very common, mechanically generated. At these areas here, of that amount, it's 75 out of 250 at the Shobra. At Alcolity, it was 100. A lot of that's resuspended road dust. So in the PM10 fraction, you tend to see a lot of soil. The interesting part here is, here's the lead. And the lead is running at over 50 micrograms per cubic meter. Lead, average during that period. My mind always goes to what's the standard, because that's a metric. If you look at the US lead standard, it's 0.15 microgram per cubic meter quarterly average. That's an average over any quarterly period, 0.15. So here we're seeing over 50. So obviously severe lead issues for what we have. If you look at these other sites, you look at Kaha up in the north. And again, this is more agricultural. This is in the Delta. They were averaging, over 75 microgram per cubic meter. But something very interesting when we saw it, this red over here, ammonium chloride. What is it? Why? So that raised questions. So we're sort of looking at this. You see the typical stuff. You see your soil, you see your cars, you see open burning. You can start looking at things. If you look at then the more recent work, and looking at everything together, this is the PM10. As we go through, we look at the winter of 99, the fall of 99, the fall of 2010. I did the summer of 2002 and the summer of 2010, so I think you can cluster by period, although, as we all know, the meteorology varies. So you always have those factors to look at. But here's some of the interesting things. Let's look at Shobra. Here's Shobra, 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 Shobra. We worked with the government to move the Abdallah smelter out of this area. So we moved one lead smelter. There's still a lot of secondary lead burning, secondary lead, taking batteries, throwing it in, and melting it, under conditions something we can talk about. But look at what happened. Here's the lead. Here's the lead. Made a big difference. I'll show you some of the numbers. Here is Kaha. Here's that ammonium chloride. We were able to knock that down. What we found is there was a bleaching operation using chlorine in the Delta. Got them to clean that up, made a big difference. Obviously, still high levels, but we're starting to see improvements. Here's PM 2.5. Again, you can look see the variability. You can see, here's 50 microgram per cubic meter. If you look at it and you look at the standards, the US standard is 15 microgram per cubic meter annual average. The 24-hour standard is 35. So, here we're seeing significantly high levels. Here again, you can see so you've got a mix of conditions. You've got your emissions coupled with your meteorology. All of those are very important. But again, you can see what the importance of species are. So here's geological, relatively small. Biggies, motor vehicles over here. You see open burning, but we're starting to get a handle on what they need to do to improve things. Of course, with the current situation, things are not working that well there, so who knows what's going to happen. But we're able to give them this information. We are able to see some improvements. If we looked at this data over here, these were the lead levels, and really, if we look at both the PM10 and the PM2.5 fraction at the Schober site, you can just see that tremendous drop over there. So we're able to see that improvement from something like lead, where we had incredibly high levels. If we look at things like hydrocarbons in the air, Alcohol is a multiple source dominated site. We're seeing almost 2 parts per million of speciated hydrocarbons. I'm not talking methane. Okay, methane, that's common. Not for the hydrocarbon species. So incredibly high levels, most of which are coming from multiple source leaks, other things like that. I wanted to throw this one in because one of the other things we often look at are polyaromatic hydrocarbons. In this case, we use them because we use them as part of our fingerprinting for the receptor modeling to determine the sources over here. We looked at them from all sites, very high levels. The highest happened to be at El Cololi, the mobile source dominated site, and we saw over 10,000 nanogram per cubic meter. Now, in this case, we normally talk about nanogram concentrations or even picogram concentrations, much higher. At one of the sites that we looked at, we actually saw benzoate pyrene alone exceeding 1 nanogram per cubic meter, and as high as this was a 24-hour sample of 570 micrograms per cubic meter. The people in the lab were going crazy, like how can we even analyze these levels? So the pollution levels in Cairo are extreme. If you look at it, you've got roughly 1/3 of the country's population is living there in tremendous, many of them in tremendous poverty. So it's truly a challenge for what you have. They're exposed to very high levels of pollutants. Some of the soil, multiple source emissions are important. Open burning is incredibly important. And we're working with them to improve things. By the way, has anybody here ever been to Cairo? Okay. Only a few of you. It's close. Not too many. So you've probably seen it over there. But of course, if you've gone as a tourist, you don't see a lot of this. I get to see the industrial areas. But it's fascinating to see what goes on there and what can be done. But the idea here is by doing this type of measurements, source apportionment work, we can then help them to clean up the air. And when you're looking at those very high levels, it has tremendous health impacts and tremendous health effects. Okay, this is a study that I did while I was here. Some work done in September. I'm also working with a company in Tel Aviv that's looking at a different technology for doing source apportionment work. This one is spectroscopically based, not based upon wet chemical analyses over here. So we were looking at, if you look at the power plant by Hedera, so here's the power plant over there, and if you're looking, let's say, at the Hefzibah site, which is fairly close by, just on the other side of the highway, people here were complaining that they were seeing coal dust, fugitive emissions from the plant. And so what we did was we set up one site just in Hefzibah, another one at the monitoring location in Pardes Khana, and use this microscopic chemical imaging technology that's based on particle fluorescence to determine the sources. For the site located at Hefzibah, we actually had a mini-vol sampler set up there, so we're collecting samples on filters every 12 hours and then analyzing using the system. For the Baroclinicity site, we had an automatic system, so every 12 hours it would rotate through and collect the sample and do the analysis. If you look at this system, really what it does is, let me skip to here. What you wind up doing is you get the samples collected on Teflon filters, you hit it with UV light, you look at the fluorescence that you have. So particle by particle fluorescence over here. And so you get these fluorescent spectra. So before I had mentioned on the Cairo work that we were collecting polyaromatic hydrocarbons. Well, polyaromatic hydrocarbons fluoresce, right? Actually, soil crystals also fluoresce. So a lot of the different pollutants that we look at in the atmosphere have distinct fluorescent spectra based upon their chemical characteristics. And so this is what we were able to make use of using this technology. So being able to split out by measuring the spectra, we in a sense have a fingerprint, built up a source profile library, and we can go back and determine how much is from industrial sources, mobile sources, soil, etc. One of the things, though, that doesn't fluoresce are secondary particles like ammonium sulfate and ammonium nitrate. So the way that we've been able to look at those is actually looking at the fluorescing particles, the total particles, and by difference, get the non-fluorescing particles, which we then assume are the ammonium sulfate, and ammonium nitrate. So we do it by difference. We see it's roughly, depending upon the area, somewhere between 20 and 25% in the Nevada case. We did a comparison of this versus some of the other samples that have been collected at DRI and looked at the source proportion results using the CMB, using this technology. And we saw that there's no absolute standard, but roughly comparing the way that we traditionally do CMB versus this method, we found we had a slope of about 0.95, R-squared about 0.7. So fairly good comparison between the techniques. So what did we see at Hefzibah? Well, first of all, this happened, some of these samples were collected during the Chagim, which meant they weren't collected over there. They weren't collected on Shabbat or anything else like that. So we have the periods missing. But if you look at it, this is percent of total going from late August through early October. Over here, you can see every 12 hours, we can look at the percent contribution from different sources. If we look at the overall average at this Hefzibah site, which is, as I say, just adjacent, just on the other side of the highway, roughly 30%, 29% was from the power plant. A little over 11% for fugitive emissions that we saw, coal fines, others. Other industrial sources, about 9%, about 30% mobile sources. Soil and road dust, some burning, cooking, port activities, just the ships that deliver the coal. We actually saw them over there, and about 75% unidentified. If we take this, combine it with data from the EASC over there, we can then take that percentage, multiply by the total observed TM concentrations over here, and then get contribution in terms of microgram per cubic meter. So we can work it out that way. So this just shows that for the period. If we look at Baroclinicity, next part here, automatic. So we get it every day. So we got it. We have the Yom Kippur data in here. We have all of this data in here to look at these changes to pull this out. So we're able to look every 12 hours. What we saw further downwind, about 20% from the power plant, a little under 3% from the fugitive. Again, this is the average. industrial sources, modal sources, etc.
So could one conclude that only about 20% of the aerosols are natural?
You know, I would even say less than that because of it depends on how you define natural. If you're talking about wind-blown soil, you know, you've got over here, but some of it's also road dust that gets resuspended. So, yeah, you could say, depends on your definition, but that's what you have, what they have over there. Here's again the concentrations in microgram per meter, but to me the interesting thing is let's compare the two. So I did two things here. One, I looked at the period, you know, here's Pardes-Khana for all sampling days. Here's Pardes-Khana where the sampling days overlap the samples in Hepzibah. So, you know, that's what we have here, all sampling days and samples where we had these exact same days. Because again, at the Hepzibah site, since it was collected on filters, it wasn't collected every day during that period. So I wanted to see when are we collecting at the identical period so I can compare the two of them. And if we're looking at that case, let's call it the overlap period. And again, this is percent of total. Percent of total. So, you know, if you have a lower level of PM at Pardes-Khana, you know, it may be a higher percent, but it may be a lower overall concentration. So keep that in mind. But again, this is percent of total that we have. And what we see here, first off, what I want to show you is if we look at the fugitives, so Pardes-Khana, more by, you know, closer to Central Hadera versus Hepzibah, closer to the plant where there have been complaints, we're seeing roughly, you know, 11–12% fugitive emissions. When we go further inland, down to about 2 to 3%. So clearly we're seeing that difference. So what we're seeing is we're actually seeing the fugitive emissions from the power plant. So when these people are complaining, what's going on, we're seeing this, it's like, yeah, you're seeing this. And this validates their complaints. Now, so that was sort of the important part here. But the thing that really amazed me in going through this and looking at it were two things. The large impact of the power plant at Hepzibah, somewhere between 20 and 30%. And similarly, even at Pardes-Khana, 20% of, you know, of the PM, and this is PM10. So 20% is from the power plant. You know, you have the tall stacks, you have the scrubber that's put in there, and you're still seeing this very large contribution. And so it raises questions, I think, about the control system that's going on. You know, are there other things that can be done? But that's a high note. The other thing is the mobile source contribution.
But the power plant emission, is it flying ash?
No, this is out of the stack. So this is the fly ash over here. This is the stack emissions. Yeah. So pretty big number.
Okay, what is it? Not ash, so what is it?
This is what's coming out of the stack.
What is it chemically?
Ooh. It's chemical. I can show you that. It's a lot of it's going to be organic and elemental carbon. I mean, the overall majority of the total mass.
So mostly soot.
Yes, basically. You know, so this over here is the, you know, again, this is from the power plant stack. This is the fugitive. This is local industry that you have. This is the mobile source contribution. It's got a huge mobile source contribution in that area. Of course, with the highway going by there and everything around town, that also makes some sense. Here's the soil, the burning. Interesting part, the port activity. So we see roughly a third or a half as you go further in. Again, makes sense. So using this system over here, we're able to get quite a bit of data. We're able to look at this situation. We're able to see the change as you go further inland in terms of the pollution and provide a lot of information for people in terms of what are the sources of the pollutants and maybe what they should consider, consider doing over here. So this is the Adara case, and this is given that other data that I told you about earlier with what gets reported. I have some questions again about the quality of the data they get reported. So summarizing this study, what we're able to see is at Pardescana, significant impact of emissions from the power plants, which I don't think we're expecting to see that high. We're able to see the fugitive emissions at the Hefzibah site, and clearly the power plants is a major contributor at both locations, and it did support the complaints that the fugitive emissions were affecting those people. So these were some source apportionment studies. So I've got about 15 minutes to. Okay, let me run through on some of the transboundary transport pollutant work. This was done in conjunction with Malcolm, and so we have HUJI also working with Aziza Akaba Special Economic Zone Authority, Hashemite University. One of my former graduate students is there. Another one of my former graduate students was at Aziza during that period. American University of Beirut, and San Jose State University. So trying to get these people all talking together, so they would talk to me, and now we then talk to everybody else. So we tried to look at the causes of elevated ozone in northern Jordan, and also determine the cause of the brown cloud that you sometimes see over the Red Sea over here. So this work is based on some of the PhD work that Erez Weinroth had done from here. Now, what Erez had seen, he had modeled, he did some of the source, started some of the emission inventory work, and had looked at, run some chemical models that said, okay, any of the plume that you have, by the time it forms ozone, it's not Israel's problem, it's Jordan's problem. Well, okay, it's narrow over there. So it makes for some interesting things, and of course, you're dealing with transboundary transporter pollutants, you're dealing with international cases. So the idea was, let's get people from these different countries all working together to look at that. Again, okay, I shouldn't show this in my but you've got, if you look at the prevailing winds, well, that's really the way they go. You've got a lot going across. That's where it's kind of below the pollutants. So what we did was we set up a series of monitoring stations, trying to look and see what happens. Can we track the plume as it goes across? Okay, question number one for any of you that do air quality monitoring is, how do you know you're all measuring, have everything cross-calibrated? Well, we took the mobile lab from here, we went down to Eilat, parked it at the border, we took the mobile lab from Aziza, parked it on the border on the other side, did cross-calibration of the two systems, then drove the mobile labs up north, calibrated on the Jordanian side with theirs, calibrated on this side, so we got over that hurdle that way. There was a problem getting stuck at the border at one point because of something that was going on. So anyway, that's another story, always fun to tell over a few years. So we set up sites, two in Haifa, T-Bone, Afula, over there, Taiba, and Irving. So we're up to get the sites set up. If we looked at the general wind losses during the period as we went across, we're actually able to sort of track the plume moving. So again, we're looking at ozone, we're looking at other things through that period. What do we see? Well, if we're looking at here's in Haifa, relatively low ozone over here. As we move further inland to T-Bone, we see higher. Because again, what do you have? As you move, it's time. As time happens, so do the chemical reactions. And so we're seeing the formation of ozone as you move further inland from those fresh emissions in, along the Israeli coast. Going further inland, you see it going higher, you see it going higher, even higher, and of course, when we go across the border, so going there, we now have fresh emissions, we have the concentration knocking down the ozone a little bit. And we can follow it this way when we actually look at the distribution of pollutants and just seeing an increase and shift as we move across, going from west to east in this case. So this is sort of fun study in where we're able to work with the different groups, work with the people both from here, work with the people from the Hashemite University, work with the people from Aziza to do this type of cross-border measurement, and we were able to confirm those modeling results that Erez had, showing the plume forming by the time, over Jordan here. So this was, what we did as part of that study. Now down in Aqaba, or Eilat, I wound up spending most of my time in Aqaba going across there. You've got, it's a touristic area, obviously people go there. A lot of concern about the water quality that you have, and eutrophication and other issues. But when you look at it, on the Jordanian side, you've got the phosphate coming in. There's a lot of phosphorus coming in, phosphorus can get some water, you've got algal growth, you've got other things that are leading to water quality issues. You also have the main power plant for Jordan. You look at the power plant in Hadera, that's about a 2,500 megawatt power plant. And I think that gives you, about a quarter of your country's power, the Hadera power plant? Roughly. Yeah, it's good. I mean, this is nothing. And by the way, this winds up being, this was on the gas line in Egypt that was always getting cut across the Sinai. So they had a lot of power problems over there. But this is just some pictures down from that area. So we set up the mobile lab. We also used the DOAS. In that, here's some, what we did is we set up the mobile lab at over here. And we had a site located in Aqaba, so we're able to shine that across here and look to see as air was moving up the Red Sea and quantify that. And so this was a picture that I took. I was on the Jordanian side looking at the light source, what we had. So one of the advantages of the DOAS measurements is to look at true NO2. And what we see in this case is we see this morning peak. Pretty consistent with what you might have with mobile sources. Fairly well distributed, again, not coming from any one direction. Similar for NOx, fairly well distributed. We see sort of a morning, evening peak. And again, the interesting part here is when we're looking at it, if we look at the lower periods, we tend to have air masses coming sort of from west to east. And when we tended to see the higher ones, they tend to be coming north to south over there. And so what winds up happening in this case is when they're coming from the north and south direction, we also saw a higher ozone. Because again, you're going across Israel, you're picking up the pollutants, they're converting, and you see the higher ozone when you are down in that region. On the other hand, when you look at sulfur dioxide, that's coming from the Red Sea itself. Why? Ship emissions. Okay, so you see that. So we're able to get a handle on what's causing. If you look at the nitrate radical, again, that's involved in the ozone formation cycle from the north, confirming that it's the transport that we have. PM10 again blowing north and north. So we're able to, as part of this work with these different people, look at it, look at the different sources, where they're coming from, what's important, and really try to develop, do some fun science, but also develop some of the collaborations among the different groups. And that, as I say, was fairly challenging. Working with the Jordanian government people, that worked pretty well. Working with the Jordanian University people, even though one of the people had been a former student of mine, matter of fact, just wrote him a letter of recommendation for another job a couple of weeks ago. Very difficult, very challenging. He was willing to work, a lot of his colleagues made it difficult over there. And the person that we're working with at the American University of Beirut, you'll notice I didn't show any Beirut data. That was totally separate from all of this work. Some of the other fun stuff in the next few minutes, I'm going to again go through this fairly quickly. Question here was, during the last Gulf War, are there issues related to air pollution affecting health of the troops fighting in that region? That was the problem during the first Gulf War. This came up. So we actually had some work funded by U.S. Central Command to do sampling. We didn't do the sampling. We sent the samplers to the field, and specialists on site did the sampling. Well, if people in the Israeli army or anything like people in the American, they like to try to break things in their spare time, so we had to make things as robust as possible because you've got young people trying to play with things and do all sorts of things. So this was what we had set up. As I say, work was for CENTCOM, we were trying to get data related to future potential health problems. Here were some of the sites that we had set up. So we had 15 sites set up in the region. Some of these, for example, the Baghdad site was set up in Camp Victory, which was one of the main U.S. bases over there. So we had to create all of the garden spots over there. We were sampling and just doing the samples. This was a picture from Cairo, but we basically used the same wave-all sampler. These are pretty robust. They work on batteries. During this period, we sort of rotated through. They wanted both TSP, PM10, PM2.5. We figured we couldn't send 3 samplers because it's tough enough to get them to do 1 sample at a time, much less 3. So we sort of rotated through and collected. We did Teflon filters, quartz filters, and nuclear core over there. Followed an EPA 1 and 6 schedule. During that period, believe it or not, we had 88% data collection, which I figured, considering the situations, that was pretty good. You probably have regular field programs here where you don't get 88%. So that worked out well. The quartz filters, those were analyzed for organic carbon and elemental carbon. Teflon was for the mass and also for IC and XRF. Nuclear core was for scanning electron microscopy. So that's what we're looking at in these spaces. This gives you an idea of what we collected. And so we've got a tremendous amount of data on what the chemical and physical properties of the aerosols were like. So if anybody's interested in any of this data, I can share this with you if you want to see what are some of the characteristics of the resuspended soil or whatever in those regions. We've got that. Okay, and that's available over here. Just some of the idea of what some of the chemistry was like in terms of the soil characteristics versus the others, and obviously what we're seeing is a lot of the desert dust. We also have again the SEM work. This one over here is more of a combustion particle, and for the general outcomes, both sites were high, but not unusually high, except during the dust events. One of the interesting things is we actually got them to shut down the burn pits. Because what they would do at these military bases is that for their garbage, they'd throw everything in the burn pits and just burn it. We saw incredibly high levels of things like cadmium, lead, zinc. So they shut those down based upon what we're finding, because we were getting them this data within 2 months of collection. So that was one of the outcomes of this in terms of what we're out to do and how we're out to at least try to clean things up. But again, great database that we can do. So one final thought here, and thank you for your time. I know I've thrown a lot at you, is by doing this collection of ambient particles, by doing source apportionments, we've developed strategies to improve air quality. And that's really our overall goal. We often have a lot of policies. How well do they work? This is one way of looking at it, and this is an important part of doing that. Obviously, many people involved with this, and sponsors, collaborators, and personnel from DRI. So again, thank you for your time and interest. So thank you.
Where exactly does it sit? What kind of particles? They just atoms, or it sits on specific particles? For the lead.
Oh, the lead?
Yeah.
No, the lead is actually within specific particles, because generally you have something like a lead smelter, and you know, we often think, and I should have said this, we often think that you've got lead and gasoline, so a lot of it's from the lead and gasoline that comes out and condenses. No, they use unleaded gas. So in this case, it's actually lead smelters where they are processing lead, purifying it, and so you get the lead vapor that will, you know, very, when it gets atmosphere cools down, it will condense on other particles itself, or on itself if it's high enough concentration. So it's within the specific particles emitted from the source. So that's so that's where it sits. Yeah. And then if it's PM 2.5, that's going to get into your lungs, get absorbed into your bloodstream. And so that's one reason why we're seeing such high, evidence of the lead exposure, you know, especially in the case. Yes.
I was struck by the fact that to see, at least in a lot more SO2 from ships than from land-based sources. Is it the case also more region-wide? And is it also for SO2 or also for sulfates?
That was strictly SO2. For sulfates, when it comes to region-wise, it's not going to be the ships. You've got many other sources. Obviously, you've got the power plant sources. You know, those are fairly major SO2 sources. But I always think of ships, especially when they're burning bunker fuel. Those are local power plants. That's what they are. And they're burning the worst quality fuel you could think of. So that didn't surprise me down there. Now, I'm not sure of the quality of your diesel fuel here. You use a lot of diesel in your trucks, not in your light-duty fleet. So that's somewhat different. Your light-duty diesel's fairly
sulfur lead.
Right. So regionally, my guess is you probably have more from your coal burning. But in that case, you did have the port activities. You did have the winds that come from that direction. So that's where we saw the ships.
I guess it's a concentration to that. Just now cited. I mean the SO2. SO2 and southerly winds in Eilat. I mean the southerly winds in Eilat are usually associated with very unsettled atmosphere. So the concentration should be even more than that if the winds are not, associated with unsettled atmosphere.
So it's always going to have an effect, and that's why when I was talking about, you know, the Cairo data, it's over different periods. The meteorology is not the same. The mixing height's not the same. The wind speed, so your dilution. You have many factors. That's why in some of this work, I find it easier to look at the relative concentrations, percentage of total, rather than the absolute, because again, you've got that other factor. As a chemist by training, okay, everything's in a flask, but our flask here is the atmosphere, and that's highly variable. So we've got that. But yes, that's another thing that will markedly affect the concentration.
And one more point. I guess that the seasonal distribution has a very strong impact on the result.
Yes.
So I guess I wonder whether the results that you obtain are based on equally sampled along the season, or for example, you have more sampling in the winter than in the summer, etc.
They are snapshots. And that's that's one of the reasons why when you do this kind of work, what we're getting in each of these cases, this happened to be, it was a 1 month period each time. It was 2 weeks sampling out of that 1 month. It was every other day. So really, what we've got here is roughly 20, 25 days of sampling. Those are snapshots. Why is it so limited? To do this work, I had to ship 20 pallets of equipment over to Cairo. Stuff got stolen in customs over there. Okay, it was a lot. Then we're sending samples back because they didn't have the laboratory capabilities to do it. So these samples cost roughly, by the time you're done, $2,000 a sample. Each filter at each site times 20 times 6, right? Adds up. You don't do this that frequently. That's actually the motivation for the work that I'm doing here now, looking at this automatic system, because you don't have to wet chemistry, you're not shipping filters, you can get it automatically every day, every 12 hours, at a cost that, rather than being $2,000 a sample for an answer, now it's about $20 a sample. You can start doing this routinely and just set up and monitor versus doing these snapshot studies which have all the uncertainty that they look at. And that's one of the issues. How representative is it? What else has changed? But we can't do these things routinely because of the cost. But maybe now we can. So that's the fun part of what I've been trying to do while I've been doing sabbatical.
Any more questions? Thank you.
Okay, thank you.
I have several questions.
Okay.
Yeah. It's unleaded gas. Right, it's all of that smelters, and you've had so much lead use that it's in the dirt. So the dirt gets resuspended. So even the dirt's contaminated.